So in this video, I wanted to go over the key takeaways from homework one. So the first portion of the question was about this idea of conceptualization in design. How do you actually do something that's called ideation? How do you come up with a product that has a value proposition, as we emphasized in that initial engineering design lecture? Well, one of the nice things, of course, about designing a product in 2023 is you have all this quantitative and qualitative data readily available to you online, particularly for a product like this that is really mass market. You just have such a wide user base. So certainly you do want to take advantage of that. Now I'm put in actual parentheses there. With all of that information that's available, doing manual inspections of these reviews might be somewhat challenging. You can consider methodologies to automate this using either natural language processing for the freeform text that's been entered in the product reviews, or some sort of just automated what word am I looking for here? Extracting quantitative information from the web using web scraping in order to develop kind of quantitative metrics that describe customer satisfaction. The hard thing about that is, unless it's like an Amazon review where those ratings are kind of broken into individual categories, it can be hard to gain a lot of information just from a single number. The natural language processing that I talked about there, that is kind of well advanced of this class, but it's going to be something that, as artificial intelligence tools continue to become more and more available, that's going to be accessible to all engineers. And there's just going to be this assumption that if you're an engineer, even if you're a product engineer or a civil engineer or a mechanical engineer, and you don't consider yourself a computer person or an AI person, people are going to look at you, particularly in small companies, as someone that can bring that level of expertise. So the one thing that I wanted to say, that I should say, I guess, in addition about that, is, of course, you have to be careful, particularly if you're automatically mining data from some sites that don't have a quality control aspect to spot bots. Of course, that could be challenging, but your big providers in online commerce like Amazon, of course, they take some action in order to try to spot, to verify reviews, basically. One of the other things I wanted to mention is don't understate your own experiences, especially for non-mass market products. One of the things we talked about in kind of creating a value proposition is this idea: if you're designing something for a space that you know particularly well, especially if it's niche, make sure to take your own perspectives into particular account and weight those according to kind of what you think about your own expertise in the space. Also, for mass market products, it's really important to just survey via word of mouth any individuals that you have the opportunity to talk to. Maybe it's family, maybe it's friends, maybe it's your professional network. But in this mass market product space, it's really good to make sure that as you're kind of sampling informal focus group to define ideation and a value proposition, that you have a strong sense of diversity in your sampling. Not only is that going to be important to get broad perspective and make sure that as engineers, we're designing products that meet the needs of our entire customer base, but in addition, what you might find is that certain types of, for a mass market product, I don't know why I'm having such a hard time saying that word today, but you might find that a particular population is just underserved by the current solutions that are in the particular market space. So that might be an opportunity for you to kind of innovate with high social impact. So two, formulation of the design is an optimization problem. I knew that most people wouldn't get this right, but particularly for mechanical engineers or product engineers, I wanted to plant this in your head early. So usually when engineers talk about actual optimization or engineering design, they're talking about taking your actual product and coming up with a set of quantitative variables, maybe their dimensions, maybe their cost, or so on, that kind of define the nature of your actual design. And then from that, what you want to try to do is formulate a function that can be optimized. And by optimize, we mean either maximize or minimize. Maybe it's minimizing cost, if that's one. If you can express cost as a function of your design variables, or maybe it's maximizing some particular performance attribute like load-bearing capability, or so on. And in addition, if you have that expression in terms of your design variables, what you would like to do is not only express a function that you want to maximize or minimize, but also come up with a set of constraints that can also be expressed in terms of that function as well. So in terms of those design variables, sorry about that. So maybe you can express the total weight of the product in terms of those design variables, and the weight has to be less than a certain value, or maybe a particular these design variables correspond to dimensions, and the dimensions have to be within a certain range, and so on. But mathematically, an optimization problem has an objective function expressed in terms of design variables, and then there are some constraints on those design variables. And what you're trying to do is to identify values of the design variables that fit within the constraints. Those are often called the constraints define a feasible region that is optimal, either maximizing or minimizing that objective function. Part 3, creating preliminary design end products to gather initial customer feedback. I was impressed by some of the sketches that I've seen so far. One thing that I wanted to emphasize, and it kind of relates to the course material that we've discussed until now, is that sketches don't have standards. They're not used for formal engineering workflows like manufacturing or quality assessment, like after you make a part, actually making sure that things are within specification. The real objective, particularly in the use case that was defined here, is to convey as much information as possible. So don't feel like you can't add text or add arrows. Add as much markups as you want in order to convey the important information as quickly as possible. And note that that important information, one of the things that it really is anything that differentiates your product relative to other competitive products. So if you're adding a particular feature, you might want to draw out an arrow and kind of write some text that describes that. Because given that use case, really your only goal is not to necessarily adhere to a standard, but get the important information across as quickly as possible. Here about the question of, what are we looking at? The value of creating a 3D model versus your hand sketch. Well, obviously, unless you're a wonderful drawer, which many of you are, if you have a 3D model, you're going to have increased photorealism. People are going to be able to know and actually see what you're talking about better than something you could draw by hand. In addition, when you translate into an actual CAD model, you have the capability not only to convey your ideal better, but utilize engineering design tools. Maybe you can see whether or not you're violating any spatial constraints or so on. We don't need to go into the details of that now. But finally, if you have it in a 3D CAD model format, of course, if it's something that can be 3D printed, you have the capability to interface with those automated manufacturing workflows easily. Because nothing, even if you have a representation in the 3D model, if someone is looking at it on a computer or maybe in a VR headset, there's going to be, for the majority of products, you're not going to be able to convey to an end user the all of the attributes that you want, like the textures, the prints, the colors, the actual way that it works, like you will if you have an actual 3D print. And you might say, well, a cheap 3D print isn't going to look like my desired end product either. And that is true, but it's better than just having something in a two-dimensional representation, of course. So there, if you had anything about just conveying the ideal better or being able to interface with automated 3D printing workflows, that is great. And part 4 here, the role of prototyping in design iteration. One of the things that I really wanted to emphasize here is this is getting into basically doing A/B testing, or basically taking a focus group and seeing how well your prototype that ideally you've manufactured or created in part 3 fulfills users' needs. And of course, part of the thing that I really tried to emphasize in the lectures and the videos is that you're never going to have, if you spend all your time trying to have a perfect prototype, it's just going to take too long. So oftentimes when you want to, of course, one of the key idea that we tried to emphasize in this video is that the engineering design process is iterative. It's something that you're going to do a bunch of times. So if you wait forever to get the perfect prototype, it's just going to take too long. So the key is when you're trying to implement prototypes, to capture certain attributes of the product within that prototype. Maybe it's the color, maybe it's the texture, maybe it's some measure of usability, and get that out in front of the end users or the stakeholders as quickly as possible. And ideally, if as part of that process, you can actually do a little bit of testing and get quantitative data that assesses usability, user preference, and so on. And it doesn't just have to be quantitative. Of course, it can be qualitative as well. That provides incredible value. But what you want to do is to get a data set that can be used to improve and iterate on your design. So I might have taken off some points there if I didn't see a plan where you said, hey, after I make this prototype, my prototype will emphasize these key aspects of the product, and I'm going to get it out in front of an end user, and I'm going to take a group of end users, and I'm going to test that aspect or value proposition of the product. I'm going to get some data, and from that, I will go back and improve my design. So that's, I think, probably I'm guessing based upon the submissions I've graded so far, where the majority of points will be deducted. But if you have any questions on that, do feel free to reach out. And I hope this video was valuable to you in kind of taking away some key lessons from the learning outcomes associated with the first homework.